Okay, section 6.5, inverse functions, trig functions. We're going to start with the first one, which is the inverse of sine. So you know it as sine inverse, but you also need to know it as arc sine x. So we'll learn what the domain and range of that function is. So first of all, we are going to learn how to sketch it. So this is example 13 as well, by the way. So we're going to sketch, part of the graph of sine that's 1 to 1. So we are going to pick between minus pi over 2 up to pi over 2. And there you go. And this is in radians, so you can compare the actual scale, because if you convert that into non-exact answer, this is going to be more than 1.5. So that's why I've sketched it like this. So imagine as reflecting it in the line y equals x. So effectively what you're doing, you are flipping the values on the y-axis onto the x-axis and the x-axis onto the y-axis. So your pi over 2 will go here and your minus pi over 2 will go here. 1 is going to be somewhere here and minus 1 will go here. And then you imagine, you know, in terms of sketching, you want to flip this graph, which is your sine, in this line. Okay, so you kind of need to draw that shape. There you go, a little bit like S shape. So we're going to start with that point here and end with that point and drawing that graph. So in many ways, when you do that, you can just draw it. Okay, so I had a little practice here. If you wanted to learn how to draw it quickly, you can, remember, do the sine graph, but let's do it without the axis. So even if you just slightly axis there, part of the sine graph that looks like this, and then you quickly draw this, the other side of it, if you like. There you go. And then all you need to do is just make sure you put the numbers. So here you will have 1, minus 1, pi over 2, and then minus pi over 2. There you go. So draw bottom of the sine, fill it in with the top, and the filled in top, the black one here, that's your arc sine. Okay, you can only do it if you choose part of sine graph that is 1 to 1. So that gives you restriction on the domain and the of the original graph, and therefore the range of the inverse function. So let's just write the key features. So the domain of our arc sine is simply whatever the range used to be for sine. So it's going to be x is between minus 1 and 1. The range will be your whatever x values you were drawing your sine graph for. So it was between minus pi over 2 up to pi over 2. And that's the y values, that's your range. Okay, we're going to do exactly the same for cos and arc cos. So the inverse of cos, so cos inverse, is written as arc cos, 2 c's next to each other. So how do you sketch it? So this time we're going to sketch your cos graph. Again, you want to sketch only the 1 to 1 part. So you're not going to draw it from minus pi over 2 to pi over 2, because that's many to 1. So you're going to sketch it from 0 up to pi. That's why it's a little bit harder, I think, than the other graph. Okay, so what happens here? Now we are going to swap whatever was on the x-axis with the y-axis. So let's imagine pi over 2 will be here, and this will be pi, and whatever was on the y-axis will go on the x-axis over 1 here. So this point here was where my purple graph crossed the x-axis. Now this point here on the y-axis, it was where its inverse will pass through. We went through here that 1 used to be here, minus 1 pi. So I need to go to minus 1 pi. So I'll be going from here and I'll finish over here. So imagine actually reflecting this in like this quickly. So you want to do the graph like this. But here, what you need to realize that this is the shape. This is only so you know the shape. So this is your starting point and this is your end point. So we need to do, so in many ways you can still look at this. You need to draw that kind of graph, but we are going to draw it over there. There you go. So we're going to draw it from 1. This. So it's not going to be on the other side of that graph. It's going to be shifted because that's your starting point, that's your end point. So there you go. So the arc cos completely stands on the x-axis, is above the x-axis. And so when I schedule, let me go through that again. What you want to do is do your cos graph. I think it helps personally, but you only want to go from 0 to pi because you want to only pick the section that is 1 to 1. And then the key thing is to change those key values here, flip them onto the y-axis. So pi over 2, and this is where your new graph will go through, pi, okay, and then your minus 1 and 1 will be moving onto the x-axis. So you will have, you used to be at 0, 1, now you are at 1, 0. So 0, 1 goes onto 1, 0. You used to go through pi over 2, 0. Now you will go from 0 to pi over 2. And then at the end, it used to be from pi minus 1, and you need to go to minus 1 pi. So where's minus 1 pi? Over here. So I'll need to start from here and end up here, but the graph needs to go that way, like that. There you go. Just, I know that this is some students struggle with, that's why I took my time twice to go through that. Okay, the domain, you can just read it from the graph. So the domain is again LDXs between minus 1 and 1. The range again, you could see from 0 up to pi. So from 0 up to pi. Brilliant. Finally, we've got tan inverse graph, which is your arctan, predictably. So this one here, again, we want to pick a section that is of tan, that is 1 to 1. So we are going to pick the whole part from minus pi over 2 up to pi over 2. So from the one asymptote to the other. So to sketch the graph, what will happen, remember with the asymptotes, they change as well. So they were vertical, now they are going to be horizontal. And they will remain the asymptotes at pi over 2 and at minus pi over 2. And you need to imagine reflecting this shape. Again, it's kind of, at the moment it's going up like that. So now you need to do this. Because you want to change that movement here. So like as if filling in those gaps. It's imagine reflecting in the line that is going diagonally across. So this is what we're going to get. There you go. So the domain, so it used to be the range for tan, that is unrestricted. And the range is between the asymptotes, not including the asymptotes, so not equal. Okay, so we're ready now to move on to example 14. We're going to find in radians the values of arc sine minus pi over 2. So well, think about it, this is like sine inverse, so it is if you imagine dealing with sine x, that gives you sine x is equal to minus root 2 over 2. So it shouldn't be really that difficult. So for what value of x do you get minus root 2 over 2? When you know that x is here in this particular instance were restricted between minus pi over 2 and pi over 2 for arc sine. So this is x is equal to minus pi over 4. Because remember, your x is between minus pi over 2 and pi over 2. You're only looking at that part of the graph. Our cos, so really, it's you must have had cos x is equal to minus 1. Remember, for x in this particular instance, it goes from 0 up to pi. Okay, so you need to find the value when it's equal to minus 1, so x is equal to pi. Arctan, so here there's no restrictions, so tan x is equal to root 3. So what angle will give me root 3? So x is equal to pi over 3, and then it will repeat, so you'll have 4 pi over 3, etc, etc. I'm not sure if the book does it as a restriction. They've only stuck with pi over 3. Okay, so you're now ready to go and use this new notation really to describe those sine inverse, cos inverse, tan inverse in the questions in the exercise 6E.